Hi everyone, so I'm Hiranya. So I'm today's TA for the experiment number 2, which is the determination of acceleration due to gravity. And so let me begin with the definition of accuracy and precision. So accuracy is actually something how close your data is to the actual value. Precision is how far between your data points. The quantitative measurement of precision is the standard deviation. So if you have high standard deviation, you have low precision. If you have low standard deviation, you have a high precision. So that is simply accuracy and precision mean. The whole point of this experiment is to determination of acceleration due to gravity. And here we are going to use an Atwood machine, right? So actually you may have heard before the Galileo's experiment, which is falling something top of the building and measure the time, and you can even measure the gravity. So in this one, you're going to use this kind of a pulleys right here, right? So, and there are a couple of pulleys here. And this is what we call the Atwood machine. So Atwood machine can help us to determine the acceleration due to gravity, acceleration of the system, and so on. So all right. So the first part of the experiment, which is part A, you have to use this kind of tube, right? So and you have a mass hanger. And the first part of the experiment, which is part A, you need to put masses until you get 260 grams in this tube, right? So you can easily use a balance to check that, right? So now it is 260 grams in this side can, right? For the whole mass of this tube is 260. And if you take this one, the mass hanger, this is 240, right? So you can see that I taped these masses into the mass hanger. Otherwise, when it hits the floor, it will be flying off, right? So you need to take that precaution before you do the experiment, right? All right. So you can see the pulleys are here, right? So and there are a couple of things I want to mention here, right? This is what we call the photo gates, right? Actually, photo gates detects when something goes through that photo gate, right? And here, this is the timer you have to use, right? So actually, there are two quantities in this lab, which is called T1 and T2 in the first part of the experiment. T1 is being the time that passing through this first photo gate, right? And T2 being the time that that tube passes through this second photo gate, right? So you're going to measure T1 and T2 using this timer, right? So make sure that you have switched this timer to gate mode, and you turn the memory mode on, right? In the first number you see here is a T1, right? Actually, I'm going to show the demonstration, then I can explain you how to get T1 and T2. All right. So make sure this tube should be in the photo tube side, and the mass hanger should be the other side, right? So and like this. All right. So and make sure that you reset this timer before you do the before you do the trial. All right. So let me show this, and make sure that every time before you let this go, make sure that the mass hanger touches the floor, right? Otherwise, you will have different kind of acceleration of the system because you release the mass hanger from different heights, right? So always make sure that you start with the floor, right? All right. Okay. So let me show this. All right. So this is what we have to do in the first part of the experiment. And so let me show how to get T1 and T2. Right? So the first number you see here is a T1. Right? And when you switch this memory mode, the second number you get is T1 plus T2, not just T2, right? So you have T1 data and you have T1 plus T2 data. So how do you get T2? So just subtract two numbers, right? So you can subtract T2 to get T2. You just take subtraction of those two numbers, right? So that is how simply you can do this. And once you have all the data of T1 and T2, you have to carry out some calculations, and you can easily use your equations you are given in your lab manual to determine your acceleration of the system as well as acceleration due to gravity. So that is all about the first part of the experiment. In fact, actually, you need some measurement before you're doing your calculation, which is the length of this tube, right? Which we call simple d, right? Little d. And you will need the length of these tubes, right? Which is we call big L, right? So you're going to measure this using this kind of a ruler. Right? You can measure this one using kind of a ruler. And in one question, you are asked to present the uncertainty of this measurement, which is the uncertainty of the measurement of the tube and the uncertainty of measurement of this length between the two tubes, right? That uncertainty will be the uncertainty of your instrument, right? Measuring instrument. So in this case, we're going to use, since we're going to use the ruler, right? The uncertainty is the uncertainty of the ruler, right? So uncertainty this one is just 0.05 centimeters, right? Make sure about your units, right? Make sure everything every unit is. You are using same unit throughout the experiment, right? It may be centimeters or meters or whatever you are convenient with. If you say centimeters, so the uncertainty of this ruler is 0.05 centimeters. So make sure about that. All right. So that is all about the first part of the experiment. So so you have to do a couple of times. I think 5 times, and take T1 and T2, and you're going to carry out some the calculations before you get to gravity of acceleration. All right, so that's all about the first part, and if you then we can move to part B, right? So you're going to do the same, right? You're going to do the same, but this time you don't need this. Part B, you don't need to use these photographs. You're going to measure that time using a hand counter, right? Hand timer. So actually, in the lab, we can use this kind of a hand timer, right? So you can use this, but easily you can use your phone, right? Mobile phone to, you can use your stopwatch to measure the time easily, right? So whatever convenient with you, you can use either this one or just your stopwatch, right? And this one, you'll need just the time, right? You don't have any T1 and T2 because you don't have these photo gates anymore, right? So you just need a single time, which is we're going to measure now. And make sure that this one, the mass handle, touches the floor, right, before you do this. All right, so still you'll need the length of the tube, no, not the length, so then cut that down, right?
Yep.
So actually this one, you're gonna need the distance or the height to the tube from the floor, right? So you can measure easily using a ruler. And still, the mass of this one is 260, and the mass of the mass hanger is 240 grams. All right, so I'm gonna do this, right? And you can reset your hand timer or your stopwatch, and we're gonna count this one. All right. So when at the time that touches the floor, you stop the stopwatch and you're gonna take that time, right, as your time measurement. So as before, you can easily carry out some calculations to find the system of the acceleration of the system, and finally you can determine the acceleration due to gravity. So that is all about the part B. Repeat the 5 trials, I think, so you can take the time measurements of this system. So we're gonna move to part C of this experiment, right? So actually this one, the big difference is you're going to use this pulley, right, instead of this pulley, right? So, and make sure that this pulley is way heavier than this one, right? So make sure about that, because you'll need this fact to answer your further questions in your lab. So make sure about that, right? This mass of this pulley is way heavier than this one. And so instead of a tube, now you'll need 2 mass hangers, right? So you'll need a different masses in each mass hanger, right? For instance, the first case, if you take this one as M1, if you take this one as M2, right? In the first case, you'll need M1 to be 105 grams and M2 to be 100 grams, right? The second one, M1 should be 110 grams, M2 should be 100 grams, like that, right? So you have to repeat 3 trials, right, for each one. All right. So for the counter, right, you're going to use the hand counter for this one as well, right? Or you can easily use your stopwatch or the mobile phone to capture that time, right? So that's all about the time. All right. So you're gonna repeat the same. Make sure that this, the lighter mass hanger touches the floor, right? And you can release this one, and you're gonna start counting, right, on your stopwatch or your hand timer, right, like this. Right, you're gonna stop that timer at that moment when this one hits the floor, right, and you have all the times. So you have that time measurement, and make sure that you have measured that this length, right, this height from the floor to this mass hanger, right, which is we call capital S, right, and you'll need this one to calculate the acceleration of the system. Then the next part, right, you're going to use these rings, right, and you're going to add these rings to this pulley, and you're going to you are increasing the mass of the pulley, right? Make sure about that, because you need this one, right? So you are increasing the mass of the pulley, and so you can use these screws, right? All right. So now we have this pulley with one ring, right? With one this kind of a ring, and you're gonna repeat the same, right? So and you can count that time, right? You can get easily that time measurement, right? And you're gonna repeat with another ring, right? In your table 5.1, right? You'll need MR equals 0 means you have no rings. MR equals the second column is about with one ring, and the third column is about 2 rings, right? You can add another ring to this one, right, like this, and you're going to repeat the same with varying masses, right? All right, so that's all about part C, and you're going to carry out some calculations, and you're going to plot 3 graphs on the same plot, and you'll have some conclusion from that plot. So that is all about the demonstration.